Yes. So in the last class, what did we see? Means in the class on Tuesday, we started with geometric progressions. Okay, the series part is not for the boards, that we will not discuss today. From the Monday and Tuesday, we have already started with geometric progression, and in geometric progression, uh, we have discussed. Okay, the first sums were related with similar to AP only. If two terms are given, let's say two terms are also given, then how to find the next term? Let's say A in the, let's say, eighth term and 12th term is given, how the next term will be related. The only formula that was there similar to arithmetic progression only, nth term is what? First term into r to the power n minus 1, that is n minus 1 steps ahead. So the step approach is there, and after that, doing some sums over this, we went over the concept of inserting number of terms between two fixed terms. Okay, so inserting number of terms between two fixed terms. So let's say insert two numbers. There also the step approach. When you insert two numbers, you are dividing that interval into three parts. And these three parts actually not equidistant. In arithmetic progression, they are equidistant. In geometric, they are not equidistant. So the multiplying factor is r cube and did by that method. That was the second type of problems. Third type of concept was this important remark. If A1, A2, A3, A4, An are in GP, then Pth, Qth, Rth, Sth terms are also in GP, where PQ, Rs are in AP. The example of related to this was here. 10, 11, 12, 13, 14, 15 up to 20 means term 10, 10th term, 11th term, 12th term. If this is a geometric progression, then 10th term, two steps ahead, 12th term, I will have to multiply by r square, two steps ahead, 14 r square, two steps ahead, 16 r square. This will be a new GP. 10, 14, 18, 22, 26. This will again be a new GP with common ratio r raised to 4 and so on. We did one sum related to this. A 10th term is given, 20th term is given. Find the 15th term. So without actually knowing, without actually calculating the exact value of r, we were able to calculate the 15th term. So that was the application. And after this, lastly, we saw sum of n terms of a geometric progression. So sum of n terms of a geometric progression is equals to the formula that we derived. How the concept was, r times Sn, we write again, and then subtraction. This is the first surviving term, last surviving term. So this much part we have covered. And some numericals up to sum of n terms of this sequence. So today, first let's say now summation symbol, also every one of you is aware what the summation and properties of summation symbol. So evaluate k is equals to 1 to 11, 2 plus 3 to the power k. This term, the answer to this question will involve something 3 to the power a very large number. So don't calculate that large number. It means obviously by hand you cannot calculate. 3 to the power 5 itself is 3 to the power 6 itself is 729. Here you may require 3 to the power 10, or maybe 3 to the power 11, or maybe 3 to the power 12. So let it be like that only. Just answer me in terms of 3 to the power 11 or 3 to the power 10, something like that. Done? Is it over, students? This will be equal to the summation of 2 addition summation of 3 to the power k. Afrin couldn't hear me. Okay. Others, Pujita and Dhananjay, for you, is it clear? The means the voice I'm talking about.
Yes, sir. Clear, sir.
Okay. So have you completed the question?
No, sir. Explain, sir.
K equal to 1 to 11. K equal to 1 to 11. Summation of to this first summation is equals to 22. No doubt till this part. 2 plus 2 plus 2 up to 11 times. 1 to 11. There are 11 number of 11 repetitions. So 22. And after this here, what is the second summation? The second summation is 3 to the power 1, then 3 to the power 2. When k is equals to 3, it is 3 to the power 3, so on and so on and so on up to 3 to the power 11. Can you observe that this is a geometric progression? Into 3 into 3 into 3, yes, no? Where first term of the geometric progression is 3 and the common ratio is also 3, and the number of terms is how much? The number of terms starts from 3 to the power 1 to 3 to the power 11. So there are 11 number of terms. Be careful that yes, there is a slight chance of silly mistake. Sometimes the series starts from 3 to the power 0, and 0 to 11 there are not 11 terms. 0 to 11 there are 12 terms. So that avoid that kind of silly mistake. So this 22 will remain as it is, an addition of this geometric progression. The formula that we will use is a times r to the power n minus 1 upon r minus 1. This version only because here magnitude of r is greater than 1. So to avoid the negative denominator. So it will be 3 multiplied by r to the power n. 3 raised to 11 minus 1 upon r minus 1. So that will be 2. Leave the answer as it is. Means whatever this value will be, 22 plus 3 upon 2 multiplied by 3 raised to 11 minus 1. Got it?
Yes, sir.
Okay.
Yes, sir.
In arithmetic progressions also, some properties related to our geometric progressions I will give you.
So could you scroll down, sir?
Take the screenshot. Okay.
Sir, 1 minute. Done, sir.
Okay. Now some properties of GP. First, if each term of a geometric progression is multiplied or divided, okay, is multiplied or divided by the same non-zero number, resulting sequence is also a GP, is also a geometric progression. Examples: the original geometric progression, geometric progression, let's say it is given by A into AR into AR square. You can see that the common ratio is R, AR cube, and so on and so on and so on. Now, if each term is multiplied by K, okay, here it is multiplied by K, multiplied by K, multiplied by K. Or multiplication is same as division only. Multiplication by K is same as division by another constant. The other constant is 1 upon K. Division by 1 upon K. So I will just explain for multiplication. The reason for division will hold same. The new sequences are what? A times K, A into RK, A into R square K, A into R cube K. Can you see that the new common ratio, the new sequences, first of all, the new sequences again a geometric progression. What is the division over here? The division of these two terms, ARK upon AK, is R only. The division of these two terms is again R. The division of these two terms is again R. So original sequence when multiplied or divided by the same constant, the new sequence is also a geometric progression, and the common ratio is also remains unchanged. The common ratio also does not change. Is this point clear, everyone?
Yes.
Yes, sir.
Okay. Now, after this, take note here. If each term of geometric progression increased or decreased by same quantity, increased or decreased by same number, does not mean new sequence is GP. Okay. On addition, in arithmetic progression, addition and subtraction also, the sequence was GP only. If you add or subtract this by increase each term, if you increase each term by the same quantity, or if you decrease each term by the same quantity. In arithmetic progression, addition operation is also working, subtraction, multiplication, division, all operations are working. But in geometric progression, only multiplication and division. Okay, keep this in mind. You can verify this with the example of example. Shall I move ahead? Okay.
No, 1 minute.
Pujita, Dhananjay, done?
Yes, sir.
Okay, Afrin, please increase the speed. Okay. Now, next point. In arithmetic progressions, whenever I tell you to take 3 terms in an arithmetic progression or 4 terms in an arithmetic progression, what general way we take? We can take, where is that sequence? Yes, this property. In arithmetic progression, if I tell you take 3 numbers in AP, just to simplify the calculation, we take it middle term as A and the next and previous term as A plus D, A minus D. For 4 numbers in AP, we take the middle 2 numbers as A minus D, A plus D, and we are forced that since this is a minus d plus d, the common difference should be 2 times d. So the next term will be a plus d addition 2d, that is plus 3d, and minus 2d, that is subtraction 3d. So if you take here a plus 2d, that will be wrong. This you remember very well in how we did in AP. The motive of taking such terms was only to simplify the calculations. So here also 3 numbers in AP, sorry, in GP, 3 consecutive terms in GP. Let's say if 3 consecutive terms in GP, they can be represented by AR square, but that will unnecessarily complicate things because the calculation will be tedious. So what I do, I take the middle term and the next and the successive and the previous terms, they form a pair. They form a very nice pair. A multiplied by R, and here it will be A divided by R. In the backward direction, we do the division. Okay. A into R, A upon R.
Yes, sir.
If 4 terms are there, if 4 consecutive terms in GP, if in a question you are asked to represent, you are required to take 4 terms of a GP. So now how to take some 1, 2, 3, and here it will be 4. So the pairings, now if the A upon R, A and AR, here only if you suppose increase the next term, that is AR square, that is not a very much good idea, because AR and A upon R, they will form a pair, but A and this term will be left alone. So the better idea is take this as AR and the second term as A upon R. A upon R, AR. So these two form a very nice pairs. Means upon R and R, they are not exactly, they are not reciprocals, A upon R and AR, but in multiplication of that, at least we will get rid of that R. In while multiplication, A will survive, but one variable we can get rid of. So as soon as you wrote A upon R and AR, see that the common ratio is no more R. Now the common ratio is not R. What is the common ratio? The common ratio is R square. Do you realize this part? AR
Yes, sir.
divided by A upon R.
Yes,
Next term
sir.
divided by previous term. So it will be R square. Since the common ratio is R square, I will be forced to take the next term as AR
cube.
multiplied by R square, that is AR cube. And the first term
AR
as
cube.
A upon R cube. Got it?
Yes, sir.
For 5 terms also you can do.
Yes, sir.
Okay. 5 terms, there will be a nice middle term. The third term will be a simple middle term. It will be AR and A upon R. Then it will be AR square, and here it will be A upon R square. For 6 terms and also so on and so on you can do. Okay. Third property, in a geometric progression, terms equidistant. There was some property related to equidistant terms in arithmetic progression also. Equidistant from the first term and the last term of an AP. What was that property? If you can recall, think of it, recall it in terms of step approach. So 100 terms are given, 100 terms of an arithmetic progression I'm talking about. Okay, arithmetic progression, 100 terms. So in that, if we take terms equidistant from the first and last, let's say second term, that is A2, and 99th term, one step next, one step previous, A2 and A99. What is that? What is their relation with A1 and A100? Can you recall? So their addition remains constant. The first term and the last term, their addition is equals to sum of the terms sum of terms equidistant from the first and last term. Do you recall that property in terms of step approach? In AP we wrote something like this for AP. Okay, for AP we wrote something like this: A1 plus A100 will be equal to A2 plus A99 equidistant terms, or let's say A5 plus A96. So 4 units ahead we went, we increased by 4D, we decreased by 4D. You remember this property for arithmetic progressions? Reply.
Yes, sir.
Okay, so in
Yes,
geometric
sir.
progression also we have a similar property, but here addition will be replaced by product. In a geometric progression, the product of two terms, the product of two terms which are equidistant from the first and last term is constant. And is equal to product of first and last term. So it will be something like A1, let's say A1 multiplied by A100 is equal to A2 multiplied by, sir, A2 is A1 into R. So we have an R extra here, A1 multiplied by R. So we can do, sir, A100 upon R, and A100 upon R is what? A99. Do you get it? Or you can call it as, sir, A5 multiplied by, now we got A5 as A1 into R raised to 4. So we got, sir, R raised to 4 extra. So we can call here A100 upon R raised to 4. So that will be A96. And so on and so on and so on. So so K units ahead of 1. K units ahead of 1, I can write here 1 plus K multiplied by A100. So K units ahead of 1. K units previous of 100. So it will be 100 minus K. Multiplication everything. Okay. Yes, tell me some doubts. Okay.
No, sir.
After that, the next property in arithmetic progression. Product of, which was this? Yes, this property. Any term of an AP is equal to half of the sum of terms equidistant from it. So if you want to calculate A4, you can go, sir, A3 plus A5 upon 2. A2 plus A6 upon 2. You remember this property because A3 plus A5 is what? A4 addition B, A4 subtraction B upon 2. Yes or no? So similar property, but here it will be replaced by a product. So any term of an AP, of a GP, any term of a geometric progression is equal to, now terms equidistant from the term that we are calculating is equal to square root of product of terms product of two terms. Okay, two word is very important. Product of two terms equidistant from it.
Sir, in the third geometric progressions point, sir, in the first line, what have
Shall I continue with the fourth property?
yes, yes, sir.
Okay. So any term of a GP is equal to square root of product of two terms equidistant from it. So let's say A1, A2, A3, and so on up to A100 is my geometric progression. So if you want to calculate, let's say A5, A5 is what? So A5 is equals to, you can calculate it as this way. So let's see that A5 is equals to A5 multiplied by A5 complete under root. Yes or no? So A5 multiplied by A5, it's complete under root. So if it is there, so let me do some A5 multiplied by R and A5 upon R. So this first complete thing will be equal to, sir, A5 into R is A6 multiplied by A5 upon R is A4. Do you agree with me? This A5 into R will be A6 and A5 upon R will be A4. Or I can also write it as equals to A5 multiplied by R square, A5 into A5 under root. Let me multiply it by R cube upon R cube. So what will be the result? A5 into R cube. A5 into R cube is what? So 3 steps ahead. 3 steps ahead I went. 3 steps backward also I will come. A8 into 8. So this is the property. Okay.
Okay, sir.
So you can also generalize it as, or let's say if I just write a general result, A40 is equal to A48 multiplied by AK under root. So K is equals to question mark. Answer quickly. One step answer it should be. Answer, students, if you are understanding.
Sir, this example I didn't
Did not understand. Okay. Pujita, Dhananjay, you, what about you two? Pujita, Dhananjay, what about you two? Please reply, students.
Sir, not able to understand.
Explain, sir.
Okay. See, any term of a GP is equal to square root of, so arithmetic progression means A1, A2, A3, A4, A5, or A100. This sequence I have considered as a geometric progression. Okay. So any term, if you want to calculate, what I am telling you is, my claim is, first I will tell you the property and then I will explain it. Okay. So my claim is, let's say if you want to calculate, let's say 10th term, so you can directly write the result. Let's say how 10th term, if you can calculate, 10th term will be equal to, so 10th term will be equal to a 12th term multiplied by, so you have went 2 steps ahead of 10th term. If you are going 2 steps ahead of the 10th term, also come 2 steps backwards. 2 steps backwards, with that will be 8th term, their product under root. Or so you may do, let's say, why only 2 steps? Let's go 3 steps forward. 3 steps forward, if you go 13th term, you also come so 3 steps backwards. From this 10th term, if you come 3 steps backwards, you will come at 7th term, their product under. Okay. Or you may do, so why 3 steps? You may do, let's say, sir, let us go 8 steps forward. From 10th term, if I go 8 steps forward, I will reach at A18. If I come 8 steps backwards, that will be A2, their product under root. These all equalities are one and the same. Okay. Now why is this property happening? What is the reason? So the reason is,
Sir, now K value is 32.
yes, K value is 32. Yes, here the K value is 32. From 40th, sir, 8 steps ahead you went. Also come 8 steps backwards. So 8 steps backwards, that will be 32. It will be. Yes. So now what's the reason for this property? The reason for this property is, so A8, A10, suppose we want to calculate. A10 is equals to, I can simply write, sir, A10 is equals to what? 10th term multiplied by 10th term is into under root. Did I do anything wrong here? You agree with me now?
Yes, sir.
So now here, instead of A10 into A10 under root, just concentrate what is happening inside the under root. Inside the under root only, if I am doing, so let's just do A10 into A10 is there. Let us multiply by R square, the common ratio. And let me also divide by R square. So did I do anything wrong? I'm doing all these calculations inside the under root only. Do you agree with me?
Yes, sir.
So A 10 into R square, what is, whether it is equal to A12, this thing. In A10 into R square is a 2 steps ahead. Multiplying by R square means like going 2 steps forward. Division by R square 2 steps backwards. What's so special about R square? Nothing. A10 under root. So let us multiply by R cube and let us divide by R cube. You are going 3 steps ahead. Multiplication by R cube is 3 steps ahead. Division by R cube is 3 steps backwards. Okay. Now do you realize this property? The
Yes,
reason.
sir. Yes, sir.
Okay.
One more sum, sir.
Now the sum for this question is easy. Okay. Now it's okay. Now for arithmetic progression, it was about additions. In arithmetic progression, it was about addition. Any term is equals to sum of 2 terms equidistant upon 2. 2 terms equidistant, 2 equidistant terms upon 2 equidistant terms addition upon 2. There it was plus d and minus d. A4 addition d is the next term, 5th term. A4 addition 2d is the 6th term, and so on. Okay. So generalization of result is, sir, if I write the generalized result, nth term of a geometric progression, in geometric progression, nth term will be equal to, sir, a n plus k. So k steps ahead you go. Also comes, sir, k steps backwards. Their product complete, and this is the generalized result. You can generalize it even further. Even further means what? Sir, instead of product of 2 terms, let us take product of 4 terms, but equidistant. Product of 4 equidistant terms means what? So let us do a n plus k. So I will also have to take a n minus k. So their product, but don't take just 2 numbers. Means I went k steps forward, k steps backwards. Let me also go, sir, m steps forward. So I will also return back m steps, n minus m. K steps forward, k steps backward, m steps forward, m steps backwards. All of these numbers, 4 products. Now here I will not have to take under root, but I will have to take 4th root. Think about this. Do you agree with me?
Yes, sir.
It's something like A10 will be equal to A10 will be equal to, if you are generating 4 numbers, so it will be A10, 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 A10. 4 times product, 4th root. So into R upon R. These two numbers pair, 11th term and 9th term. Into, let's say, R raised to 5 upon R raised to 5. These two numbers, they are brothers of each other. They form a pair. 15th term and 5th term. Something like that. N plus K, N minus K, these two are brothers. N plus M, N minus M, these two are brothers. Okay. Done?
Yes, sir.
Okay. So next now, but here just a slight word of caution. If R is negative, if our geometric progression is such that some term is positive, next term is negative, then this under root property you have to be careful. That is a chance of a mistake, like in this case. First term is 1, second term is -2, third term is +4, fourth term -8, fifth term 16, next term -32, next term is +64, and so on. Can you see that the common ratio is -2? Yes, no, it is a geometric progression. So R is equals to -2. So what is the problem with the property? Problem with the property is nothing but such that 4 is equals to, if you take this 4, -2 -8, previous term, next term under root. This result is correct. But if you say, sir, for this -8, I will do -8. -8 is equals to previous term is 4, next term is 16, it's under root. So this is completely wrong result. Magnitude wise they will be correct always, but the signature wise it will be wrong, because under root, we have the standard notation that under root is always used for the positive value. Okay. So they're just slight mistake of a silly mistake, a slight chance of a silly mistake. So this is the remark that will be helpful. If each term of a GP if each term of a GP is raised to the same power, is raised to the same power, resulting sequence is also a GP. So the original sequence is, let's say, AR, AR square, AR cube, AR to the power 4, and so on and so on and so on. So let us raise it to some power. Tell me which power you want. Shall we cube it everything? So it will be A cube. If I do here AR complete cube, it will be A cube R cube. Next it will be A cube R to the power 6. Next it will be, let's say, A cube R to the power 9. A cube R to the power 12, and so on and so on and so on. Can you see here that the common ratio is R cube? Common ratios are R is to 6 upon R cube is still R
Yes,
cube.
sir.
So the new sequence is also a geometric progression. Okay, R cube, cube, R cube. The new sequence is again a geometric progression. if A1, A2, A3, A4 dot 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 be in geometric progression, then log of A1, log of A2, log of A3 dot 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 are in arithmetic progression. Okay. So log Dhananjay was there, I remember. Dhananjay was present for log. Pujita, were you present for log lectures?
Yes, sir.
Okay. So A1, A2, A3, let's say A1,
Please
A,
scroll down to the 15.
geometric progression. Done, Afreen? Okay, so now A1, A2, A3, A4, this is in GP. So we know that A2 upon A1. Now let us calculate log A1. Okay, so what we know here is just that A2 upon A1 is equals to A3 upon A2 is equals to A4 upon A3 is equals to, and so on and so on and so on. Nth term upon n minus 1th term by definition. This is the definition of geometric progression. Now let's just think what happens. Consider the sequence log A1, log A2, log A3, log A4, so on and so on and so on. Just consider, I'm saying, consider this sequence. So what happens now? So if this is the sequence, yes, so log A2 minus A1 will be what? Log A2 minus log A1. This will be equal to log of A2 upon A1. Yes or no? The difference of these two terms, next term minus previous term. This is log of A2 upon A1. So here the difference of two successive terms will be, the difference of two successive terms here it will be log of A3 minus log of A2. So whether this will be equal to log of A3 upon A2, then the next difference will be log of A4 upon A3. So can you see that each of these things, the final differences that we are getting, each of these things are equal because sir, A2 upon A1, A3 upon A2, these values are equal, so their logs will be equal. Yes or no? Dear students,
Yes, sir.
just 1 second, some disturbance is coming
Yes,
from my
sir.
side. Yes. Please wait, some disturbance is coming from my side. Till then, write the next property. Okay. So let A1, A2, A3, A and B first geometric progression and B1, B2, B3, B4, Bn be another geometric progression. Then the product of the corresponding terms. If we take the product of the corresponding terms, it will be, sir, A1, B1, A2, B2, A3, B3, A4, B4, and so on and so on and so on. This will also be a GP, will also be a geometric progression. I don't think this is very difficult to prove. To prove any sequence to be a geometric progression, what do you do? So let us take this division. Term upon its previous term. What is the division? So the division is A2, B2 upon A1, B1. Let us take, so, this division. What is this division? So then third term upon second term. The third term upon second term is A3, B3 divided by A2, B2. Next will be, sir, next here it is fourth term upon third term. Fourth term upon third term will be A4, B4 upon A3, B3. So can you see that, sir, this part A2 upon A1 is same as A3 upon A2, is same as A4 upon A3, and also B2 upon B1 is same as B3 upon B2, is same as B4 upon B3. So ultimately the product is same only. This is ultimately equal. Got it? All the purple ratio, this purple ratio is same, and this blue ratio is same.
Yes, sir.
So here the common ratio will be equal to R1, R2. Common ratio here is R1. Here the common ratio is R2, some other value. So here the ratio will automatically will be equal to R1, R2. Done. Done, students.
Yes, sir.
So this is the properties of a geometric progression. Now some sums of this. The sum of first three terms of GP. The first three terms of a geometric progression is 39 upon 10. And their product is equals to 1. Find common ratio and the terms. Are you doing, students?
Yes, sir. Sir, R value 5 by 2 and 2 by 5 I am getting, sir.
Yes, correct it is.
Okay, sir.
Two different sequences, the two different common ratios, but the sequence is same only. It's just for the forward order and the reverse order.
Yes, sir. 1 minute, sir. Terms also I will find out, sir.
Explain, sir.
Okay, so see. Three terms in the GP. So three terms in the GP are there. So I will take the terms as middle term A, next term AR, and the previous term A upon R. These are the three terms of my GP. Now I will say that the two equations that I have is A upon R plus A plus AR. Yes, tell me.
Sir, for terms R equals to 5 by 2, I got 2 by 5, 1, 5 by 2.
Yes, correct.
And R
Yep.
equals 2 by 5, 5 by 2, 1, 2 by 5.
Yes, correct. A upon R plus A plus AR. This sum addition is equals to 9 upon 10, and the product will be equals to what? A upon R, A and AR. This is equals to 1. So the product is easy part. So RR gets cancelled. A cube is equals to 1. So can you conclude that since A cube is 1, A is equals to 1? This is the first condition that we got. So middle term we got. Now just substitute here. Now this was my equation 1 and this was my equation 2. From equation 2 we got the value of A. So just substitute A is equals to over here. So 1 upon R addition 1 addition 1 times R, that is R only. This is equals to 39 upon 10. The calculation multiply. So this will be equals to R square plus R plus 1 completely upon R is equals to 39 upon 10. So it will be 10R square, and 10R and 39R. So it will be minus 29R plus 10 equal to 0. So 10R, sorry, we'll take here the factorization comes out to be equal to 5R, 2R, then 2R, 2 and 5. Minus, yes. So the factorization comes out to be 5R minus 2 into 2R minus 5 is equal to 0. So R is either 2 upon 5 or it is 5 upon 2. So the geometric progression 1. What is the first geometric progression? So middle term is already 1. With the middle term already 1, that is fixed. If you take R is equals to 2 by 5 multiplied by 2 by 5, 1 into 2 by 5, then 1 divided by 2 by 5, divided by 2 by 5, so it will become 5 by 2. Geometric progression 2. Geometric progression 2. So R is equals to 5 by 2. So middle term is 1. Next term will be 1. Multiplication 5 by 2. Division by 5 by 2 is actually 2 by 5. So actually they are same thing. Both the geometric progressions are the same thing, whether you look in the forward direction or in the backward direction. Okay. Forward, backward GP, they are there. Got it? Afrin?
Yes, sir.
Did you understand?
Sir, bit, sir.
Tell me which part you did not understand.
The last part, sir.
R calculation, did you understand?
Yes, sir, that I understood.
R part you understood, no?
Yes, sir.
This was just solving the quadratic equation. So middle term, what was the terms? A upon R, A and AR. The middle term A I wrote as it is. Middle term is C A. If middle term is equals to A, what is the next term? A multiplied by R. A is 1 into R, 2 upon 5. It's actually two different GPs are there. Here they are forming with geometry. If R is equals to 2 upon 5, what is the geometric progression? A into AR. AR will be what? 1 into 2 by 5. 1 A upon R will be what? 1 divided by 2 by 5. So it will be 5 by 2. Geometric progression second will be what, sir? If R equal to 5 by 2. So can you see the three terms are actually the same only? Okay, Afrin.
Yes, sir.
Next, evaluate. Seven plus 77 plus 777 plus 7777 and so on up to n terms. The answer will involve very some number raised to n and all those things, like we did for 3 raised to 11. Don't go on bothering about calculating 3 raised to 11. Leave it like that only. It's a previous question that we solved today. Similarly, here also there will be something called as, maybe it may come that 7 raised to n, or maybe it may come 10 raised to n, or 11 raised to n, something like that. Pujita, you could have answered by unmute only. Why bother typing so much? 10 to the power n minus 1 upon 70 upon 81 minus 7 and upon 9. Yes, right, Pujita. Have you solved this question before, Pujita?
No, sir. In exercise 9.3, we have same one more, some 8, no, sir, with 8 number.
Yeah, correct.
In our school, we easy trick they said, sir. So I said fastly answer.
Dhananjay, Afrin, you are trying?
No, sir.
Dhananjay left, I think so. Afrin, should I explain?
Yes, sir.
Sir,
Yes, tell me.
sir, today they gave homework, sir, in our school in exercise 9.3, 24, 25, 26. Some, sir. At last, will you explain, sir?
24, 25, 26. Okay.
26, I'll do, sir. You explain, no, sir.
Yeah, 26 is that type of problem we have done. We will do
Sir,
24
26,
and
I'll do, sir. 24, 25, explain, sir.
okay. Okay, let's first do this question. So see, Pujita, Afrin, if we take 7 as common, so what do we have to calculate? 1 plus 11 plus triple 1, 4 1, 5 1, and so on and so on, so on, up to, don't think that the last value will come n times 1. Means repetition of 1 is n times. Just write it as n term, because sometimes it happens that the last here, if you want 10 terms, in 10 terms, in the last one it will be 9 repetitions of 1. Sometimes it may happen depending on the question. So best just go up to n terms. So now if this is equals to 7, so 1 plus 11 plus triple 1 plus 4 times 1 and so on. This is still not a geometric progression. So what I will do is I will divide by 9. This complete bracket I divide by 9, and inside the bracket if the bracket also I'm multiplying by 9. So what is happening? The thing that is happening is 7 upon 9 multiplied by 9 ones are 9, 11 nines are 99, triple 1 into 9 is triple 9, then 4 times 4 9, and so on. Number of terms is n, 2 n terms. Okay, now this becomes a geometric progression. Actually 9 plus 99 and so on, this is not a geometric progression. 9, 99, triple 9, this is not a geometric progression. But what actually is the geometric progression is, so 9 I will write it as 10 to the power 1 minus 1. Addition. 99 I will write it as 100 minus 1. So 100 minus 1 is 10 square. Addition. Triple 9 is what? So 1000 minus 1, that is 10 cube minus 1. Addition. 10 to the power 4 minus 1. Addition. Now what is the last term? So last term will be up to n terms only. So this will be equal to what? So 7 upon 9 multiplied by 10 plus 10 square plus 10 cube plus so on and so on and so on. Their addition, where there are n terms. So subtraction 1, subtraction 1, subtraction 1, subtraction 1, how many times? As there are number of terms, so there were n terms, so 1 is subtracted n times repetition. So subtraction n separate. Got it, Afrin?
Yes, sir.
So now this is a geometric progression. The first geometric progression, you know that what is the formula? The formula is a times a is 10, r to the power n minus 1, r to the power n. So this is 10 to the power n subtraction 1 upon r minus 1. So r is again 10, 10 minus 1 is 9. So that's the answer. Okay.
Okay, sir.
Exercise 9.3, question 24. Fourth sum actually you should be able to do, Pujita. Did you give your try yourself first?
No, sir, I did not write.
You did not try it and you are directly asking. At least you should try it first. Show that ratio of sum of first n terms of a GP to the sum of terms from n plus 1th to 2nth term is 1 upon r to the power n. Shall I give you some time to try? Pujita, have you tried it before, or you want to try it now?
Sir, I did not try, sir. Before only I came from school, sir.
Okay, try for some time, then I will explain.
Okay, sir. Okay. Explain, sir.
Okay. Afreen,
Yes, sir.
are you able to do?
No, sir.
Okay, let's see. Actually, there is nothing. So if you just observe, first n terms of a GP. Do you have a formula for this? So that the ratio of sum of first n terms of a geometric progression. Do you have a formula for this much part? So, no, not the ratio. No. Sum of first n terms of a geometric progression. Do you have a formula? Yes or no?
Yes, sir.
Okay, so if I have a geometric progression, first term is a, next term is ar, next term is ar square, and so on and so on and so on. Or if why write a, if there is a1, a2, a3, so on and so on, so on up to an. This is my geometric progression. So you just tell me the value of a, the first term. Just tell me the common ratio from a1 to a2. I have to multiply. The multiplying factor is r. So I will find the sum. That is sum from first term to nth term. This is not a standard notation. This is my made up notation. Okay, so don't use it outside. For our understanding purpose, I'm just writing sum from first term to the nth term. This is equals to, sir, what is the formula? So whatever is the first term, common ratio to raise to number of terms minus 1 upon common ratio minus 1. Okay, so this formula we already know. After this, nth term, if I take the next term, n plus 1th term, n plus 2th term, n plus 3th term, so on, so on, so on, a n plus n बोले तो a 2nth term. Now whether this is also a GP, so this is also a GP, nothing new in it. You should realize, you get confused at from n plus 1th to 2nth term. This is something new. This is not something new. I have just taken part of a geometric progression. First to 2nth, this was complete a geometric progression. So if I just pick up 3 terms also, for one term means here where my cursor is there, second, third, fourth, they will form a GP. Or let me take 3, 4, 5, 6, they will form a GP. Or let me pick up 10, 11, 12, 13, they will form a GP. So I just picked up a part of the original series. So the part that I picked up, that is also geometric progression. So if I just concentrate on this much part now, this is my geometric progression. What is the number of terms? Be careful here. Now here also there is a chance of a silly mistake. Number of terms is equals to last 2n minus first value, that is n plus 1, and you will have to add this one. This is very crucial. It is something like, I tell you, how many numbers are there from 10 to 15? We generally have the feeling that from 10 to 15 there are 5 numbers. Count on your fingers, there are 6 numbers: 10, 11, 12, 13, 14, 15, 16. 10, 15, sorry, 6 numbers are there. You did the counting from 10 to 15. There are 6 numbers, not 5. 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6. So we do the subtraction and addition 1. So 2n to 2n, n plus 1th to 2nth from your calculating. So 2n subtraction n plus 1, addition 1. So this turns out to be 2n minus n minus 1 plus 1. So this turns out to be equal to n. So there are number of terms is n only. Okay, sir. Now first term is what? Now for this purple geometric progression, the first term is equal to a n plus 1, and the common ratio is what, sir? Common ratio remains r only, the original geometric progression. R does not vary which part you're picking. So the sum from n plus 1th up to 2nth, this is equal to the first term, that is this, multiplied by common ratio to the power number of terms. Now I'm not saying r raised to n, I'm saying common ratio to the power number of terms. Fortunately for us, common ratio is r, number of terms is n, subtraction 1 upon r minus 1. So you have to compare now these two values. This is my first value, first sum. This is my second sum. That ratio is telling you to calculate. So sequence from 1 to n, they are ratio with from n plus 1th to 2nth. This is equals to, can you see, can I directly write the result? This is equals to a upon a n plus 1, because this factor will get cancelled out, r factor. Clear
Yes,
up to
sir.
this point? And
Yes,
this
sir.
is equal to, sir, what is n plus 1th term? N plus 1th term is what? So from the first term, n steps ahead. From the first term, n steps ahead. So it is a r to the power n. So the final answer is 1 upon r raised to n. Okay.
Yes, sir.
25th sum, Pujita, can I refer in the next class? Because I will also have to give it a try.
Okay, sir. Okay, sir.
Okay. The 25th sum I will explain the next class. So is it clear till this part? So the further, now in the next class, we will see about geometric means. Arithmetic means, geometric means, the short introduction we will see, and then this chapter will be completed. Have a nice day, everyone. Thank you.